Okie dokie, so we already talked about how to find the center of mass just in one dimension. So now we're going to do two dimensions. So I've got three particles, m1, m2, m3, and I want to find out where the center of mass is. Now, I'm on a two-dimensional plane, so I need to find the center of mass position in the x direction, and I need to find the center of mass position in the y direction. And it's actually a lot simpler than you might think. All you've got to do is find the center of mass in x and find the center of mass of y separately. So it's the same equation either way. The x coordinate of the center of mass we do just like we did before. So I've got, here's m1, so I'm going to do the mass of m1, which over here that's 3 kilograms. Okay, the mass of m1, and you know what? I should be color coding this. Back up. Oops, nope, too backed up. Let's do it in what do you call it? What is that, magenta? I guess it's magenta. Okay, so I'm going to do the mass of m1 times the x-coordinate of m1. The x-coordinate is -4. Okay. Oh, and I didn't think about it, I should be putting what these are in next to them. So this is position y in meters, position x in meters. I'm a bad teacher. Okay. Plus, do the same thing for m2. So the mass of m2 is 1 kilogram times the x position of m2. Notice the x position of m2 is actually 0. 0. Okay. Plus the mass of m3 times the x position of m3, that's 2. Okay. Divided by the total mass. So the total mass is 5, you know what, I'll write it out. 3 plus 1 plus 5 in kilograms. Okie dokie. So if we do all of that, just keep the color. So I've got the position in the x direction of the center of mass would be 3 times -4, so that's -12, plus 0. I'm going to just get rid of that. Well, okay, plus 0, plus 5 plus times oh my goodness, 5 times +2 is 10, divided by 3 plus 1 is 4 plus 5, that's 9. Okay. Notice I don't know, you might not notice this. Let's do purple. I've got kilograms, kilograms, kilograms in every unit and kilograms on the bottom. The kilograms cancel out, which is why in the end my answer is actually in meters, because my position, as it should be measured in meters, which is good. So my units are going to come out. That's nice. It's always nice when that happens, because it means you did it right. So I've got -12 plus 10 gives me a -2 on top. Bottom is 9. I can just leave it like that. -2/9 is fine. It's reduced. Or I can make a decimal. I don't have room. Oh gosh, what is that? It's -0.222 forever. Forever. Okay. Now that's just the x direction. So I know that the center of mass is somewhere at about 0.22, would be right about here. It's somewhere on a line that goes right here. But to figure out where else it goes, I need the y component. The y component is the same process, you just change everything to y's. So the y component of the center of mass, the position in the y direction of the center of mass, equals, well, I do the mass of m1, so m1 is 3 kilograms, times the y coordinate of m1. Notice this is on the x-axis, so the y coordinate of m1 is 0. Plus, I don't know why I do sound effects. The mass of m2 times the y coordinate of m2. The y coordinate of m2 is -6 meters. And I'm gonna run out of room here. Dang. Okay. Plus, well, let's see how close I can get this. The mass of m3, and I'm gonna leave the unit off to save room. times the y coordinate of M3, so that's 3, positive 3 because I'm above the axis, divided by the total mass. Now I already did the total mass. The total mass is 9, so I'm just going to kind of steal that. Okay. Do all that math, and the y coordinate, come on, of the center of mass is going to be 0, plus 1 times negative 6 is negative 6, plus 5 times 3 is 15, all over 9. I end up with, what is that? That's 9. Ha ha ha, that actually worked out really well. I totally made up these numbers. I did not mean for that to happen. Okay, so if I want to go plot the center of mass of these three objects, the x-coordinate is negative 0.22, so let's see, if that's negative 2, then that's negative 1, 0.22 would be like right here, and then 1, so it would be like here-ish. Center of mass, right about there. Okie dokie. Now, if I want to do 3 dimensions, I would have, and I don't have the information to do this, sorry, but if I want to do 3 dimensions, I would just do the same thing, but for the z-coordinates of the center of mass. So I know on your homework, you do have to do that at some point.